just telling you that you are running at reserve. So the entire world right now is running at reserve IP version 4, and some continents have already exhausted it, and they are using the same IP addresses over and over, which is giving them a tough time. So IP version 4, look at this gauge of your fuel tank, and then you see that when it's here, we have enough IP. So IP version 6 remains here. IP version 6 remains at full. It's just like you're driving and then the fuel is refilling itself. But IP version 4 is down from full. It goes all the way down to empty. It is on reserve. You can see that it shows you that it is outdated. I mean, it is exhausted. And also, because of the expansion on the internet, or because of the Internet of Things, let's just example, now we have those that are using IP address, we have refrigerators using IP address, we have cars using IP address, everything that you may imagine that is using IP address. So because of that, the address space of IP version 4 is just 32 bits, which is about 4 billion addresses. It's already depleted, it's already done. And not all the 4 billion IP addresses are used, because they provide the IP address into 5 classes, and only 3 of the classes are given. So therefore, the address space is a little smaller than that. Okay, so the routing table expansion, that is, each network will be seen as a separate network of its own. So if you have 1,000 networks, you have 1,000 route entries, and this is going to provide a lot of overhead on your router to start thinking about how to get those networks. So lack of end-to-end connectivity, because IP version 4 is smaller in size, it is divided into public and private. So the private addresses are used within the LAN, and the public IP addresses are used between LANs, and it's in the one area, and mostly by the ISPs. So your IP address version 4 private will be mapped with a public IP version 4 in the public network, and this can provide loss of packets. So for that reason, because of these problems, networkers introduced, IETF introduces IP version 6. Now the advantages of using IP version 6 is that it increases the address space from 32 bits, because IP version 4 is 32 bits. That means 2 to the power of 32, it gives you about 4 billion. So your address is just 32-bit address for IP version 4. IP version 4 came and it makes it 4 times the size of this one. So it improved packet handling. That is, it has fewer fields than IP version 6. Than IP version 4, and IP version 6 eliminates the need for NAT. There is no need for NAT, because there is enough IP version 6 addresses. We cannot use it. Even if each person is using 100 plus IP addresses, we're still gonna be left with IP address. We have undecillion IP addresses with IP version 6, so that means it stays at full all the times. So let's look at the comparison between the packet header size and a packet header for IP version 6. Now look at this. IP version 4 packet, when you are using, like say for instance, I am using IP version 4 right now, I'm sending a packet to you that is listening to me right now. Your device would receive using IP version 4. So my router would check all these fields here before it can release my packet from leaving my device to your device. If I'm using IP version 4, if I'm using IP version 6, my device will only be obliged to look at only this few. So let's count it. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Look at that. All these fields will be tested before the packet is left out. Now here, only one new field is added. All the rest are reduced. You can see you have only version, traffic class, payload length, next header, hop limit, source and destination IP address. All others, the only thing that is added into IP version 4, the only packet header that is added to IP version 6 that IP version 4 does not have is the flow level. You can be asked in an exam which of the following fields is new that IP version 4 does not have. So it is the flow control. Now all of these fields that are in black, or you can call it hash, dark hash, or whatever color, these ones that we have here, where you have the identification flags, blah blah blah, those fields are no longer existent in IP version 6. So we move. The advantages of using IP version 6 over version 4 is that it is simpler in terms of header. It is hierarchical. IP version 6 is hierarchical in nature, and it also is it provides some automatic configurations, and it also eliminates the need for NAT. So So this you may be asking an exam, which of the following are advantage or the advantage of using IP version 6 or version 4. So IP version 6 packet header fields, like I said, these are the fields, and then we have the version, traffic class, flow level, the payload length, and the next header. These are the headers. And we also have what we call the hop limit and the source IP version 4 and version 6 and version 6 destination IP address. So guys, we move to the next one, that is the routing. Routing is the process of forwarding IP packet from source to destination, and the important role of the network layer is make sure that it direct packet from between hosts. That means, for instance, it makes sure that it provide my device and your device to be able to communicate. So a host can send a packet to itself or to a local host or to a remote host. To itself means the device, like for instance my PC. I want to test whether my PC's NIC card is functional. I can test my PC from my PC itself, okay, by using the 127.0.0.1. So you can just go to your command prompt and type ping and type 127.0.0.1. If you receive a reply, then that means your NIC card is functional and fully functional. And localhost is the device that is, let's say for instance, I am with Eliman here, he is using his computer, I am using my computer, I am sending a packet from my computer to his computer because we are locally connected, because we are all on the same LAN. I am pinging Eliman in my LAN. But if, for instance, you guys that are at home right now, I am remote connecting you, so therefore I am going to use a remote address to reach to you guys. I'm going to have to ping you guys remotely because you are not with me on the same LAN. So the source IP version 4 address and subnet max is compared with the destination address and subnet max in order to determine if the host on the local network or remote network. So the subnet max right here is what tells whether the devices are on the same network or they are on a different network. So in order for routers to be able to make forwarding, in order for a packet to be able to leave the local network to go outside of the local network to another local network or to a remote network, those route devices will need a default gateway. The default gateway here is the interface IP address of a router that allow devices in the local LAN to be able to forward their packets out of the LAN to another LAN or to other LANs out there. So routers will, what the default gateway does is that it routes traffic to other networks and has a local IP address in the same address range as other hosts on the network, and it can take data in and forward data out. So that is the default gateway. What it does is that it routes traffic out to other networks, and that is exactly what it is for. So we're going to do the default gateway configuration. It's normally the interface IP address of a router that, or any device that sits between your network and the remote networks. So using the default gateway is very important. So like for instance right now I have PC1, PC2 and the switch right now. Now if I only need to communicate between PC1 and PC2, I will not need this default gateway because this PC1 and PC2 are on the same network. But if for instance there are other networks and the remote networks right here, and PC1 and 2, either of them want to connect to that network that is remote to you can see there's a network here and there's a network behind. So this router, that's what it does. So each interface of a router is a broadcast domain of it. That means it's a network of its own. So it has an interface FastInternet 0/0 or gigabit 0/0 that connects to this network, and gigabit 0/1 or FastInternet 0/1 at this other side. So this network is a network of its own, and that's a network of its own. So devices here, to be able to communicate with a device or any of the devices in the remote network, they will have to need the IP address right here of this router's interface here. So the default gateway can be configured automatically, or it can be assigned from a device that is configured as a DHCP, or in fact even the router that is configured as a DHCP router. So on a Windows host, you can display the routing table using the route print command, or you can use the netstate-add command. These functions, or the three functions, will be displayed. That is, it will provide the interface list, the IP version 4 or version 6 IP address. So how does routers make forwarding decisions? This router receives a packet from this PC or PC on this switch. How does it forward that packet to another device? It's simple. Routers must LAN networks in three different ways. That is, this network is LAN because it is directly connected, or this network is LAN, that is 10.1.1.1.0 24 network right here is LAN, by router 1 through router 2. That is a remote network, because this network 10.1.1.10/24 right here is a direct connection to router 2, but that network is not direct connection to router 1. So therefore, router 1's network, this network 10.1.1.1.0 is remote to router 1, and 192.168.10.0 network/24 is remote to router. So networks are learned in that way. Whether the network is directly connected, like for instance this 192.168.10.0, 192.168.11.0 network, and the 209.165.200.224/30, those three networks are directly connected to router 1, and 10.1.1.1.0, 10.1.1.2.0, and 209.165.200 and 224/30 are networks that are directly connected to router 2. This is very important. I am emphasizing on this because you have to understand this when you come to static routing. If you don't understand this, you will not be able to configure static routing in semester 2. Remote routes are routes that are not directly connected to a particular router. So let's say for instance router 1, this network and this network are remote to router 1 because router 1 does not have any cable connection direct to those switches, but it connects to those switches through router 2. Router 2 as well will connect to this 10.0 and the 11.0 network here, because it will connect to router 1 to know these networks. So therefore those networks are remote to router 2. And we also have another way that networks can be learned, that is default route, a route that has no destination match. So what we do is you just configure this router and say, if you have any packet that does not match your routing table, just forward the packet to router 2. That is what this default static route is. Just to caution you guys, that default static route and default gateway are a different thing. Okay, so you pay attention to that. So on a Cisco router, you can use the show IP route command to look at the routing table of your router, and you will see you will see some information. So I'm just going to make a